Welcome back to the Ultimate Exam Masterclass. Today, we are tackling one of the most notoriously tricky, frustrating areas of the Cambridge 9618 Computer Science exam. We're talking about justifying the use of a compiler versus an interpreter for given situations. Now, if you've been reviewing past papers, you already know this topic comes up constantly. It's everywhere. And yet, it's an area where an enormous number of candidates just leave valuable points on the table. Today, we're going to program your brain for maximum efficiency. We're adopting the robot engineer mindset to build automated patterns for these common question types. To really set the stage, let's talk about a real Cambridge computer science past paper question, specifically from code 9713, which heavily overlaps with our 9618 strategy. Picture two different students taking this exam. First, we've got Alex. Alex overloads his answers with raw, unfiltered computer science facts, but there's absolutely zero analysis. It's just a data dump. Then we have Sam. Sam rushes through the paper, completely missing the command word requirements. If we look at their flawed answers side by side, it is just a sea of red pen marks. Our goal today is to master the strategy that completely prevents those red marks. Let's get right to it. So, ask yourself this. Why do you keep losing method marks on compiler justifications? It's a really frustrating reality for so many students, just like Alex and Sam. I mean, you know what a compiler is, right? You know what an interpreter is, so why aren't you getting full marks? Well, we are going to use the actual Cambridge Principal Examiner reports to uncover exactly where those easy marks are slipping through your fingers. We're going to look behind the curtain to see exactly what examiners expect when you are faced with a really complex justification scenario. Alex loses marks because examiners don't just want a dictionary definition. Sam loses marks because ignoring the command word means answering a question the examiner didn't actually ask. It's literally that simple. We have to fix this foundational approach if you want to ace these papers.
Okay, let's dive into this roadmap. We've structured this explainer to mirror the exact logical decomposition required in the exam itself. First step, we'll expose the examiner's mark trap, the biggest pitfall out there. Second, we'll build up your theoretical foundations so you actually understand the core concepts. Third, we're going to implement the procedural framework. And finally, we will break down the top 3 examiner warnings to ensure your answers are virtually bulletproof under pressure.
Let's start with Section 1, the examiner's mark trap. If there is literally one thing you take away from this entire session, it's understanding this fundamental pitfall that catches even the most incredibly prepared students off guard when they're sitting in that stressful exam hall. We are going to break down the computer science-specific assessment objectives, and I'm going to show you exactly how top students structure their answers to completely bypass this trap. Here is a massive, direct alert straight from the principal examiner reports. Listen closely to this. The classic mistake is providing generic answers not specific to the question context. Guys, this is a monumental trap. Memorizing standard textbook definitions and pasting them onto your exam paper is a guaranteed way to lose points. Examiners aren't testing if you have a photographic memory of the syllabus. They are testing if you can apply that knowledge to the highly specific, sometimes incredibly unusual scenarios they present in the prompt. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to it. Remember, you have to link every single point back to the given scenario. If the prompt talks about a smart fridge, talk about the smart fridge. Look at how brilliantly this illustrates the exact difference between a low-scoring answer and a top-tier one. On the left, we have Alex's approach, simply stating the generic definition that a compiler translates the whole program at once. Sure, that's absolutely true, but it earns you very little. Now contrast that with the right side, a context-specific justification. This is where we introduce the Peel framework. Point, evidence, explanation, link. Top students make a point, provide evidence from the prompt, explain the computer science theory, and link it back to the scenario. So instead of just saying it translates the whole program, you explain exactly why translating the whole program at once is absolutely critical for the specific software company or the highly constrained embedded device mentioned in the prompt. You must always choose that right side, Peel-driven approach to secure those marks. Which brings us to our second section. Mastering theoretical foundations. To be able to dynamically apply your knowledge to any context, you have to move beyond rote definitions. You need to build a mental architecture of true, deep understanding. This is where we take students like Alex and Sam and we completely transform their answers from red marks to green check marks. Cambridge emphasizes that top-performing candidates exhibit what they call connected conceptual understanding.
What does that mean? It's the ability to transfer fundamental principles to entirely unfamiliar contexts. It relies on knowing precise definitions, yes, but more importantly, understanding the causal relationships between them. It means asking yourself, if I change from an interpreter to a compiler in this specific hardware environment, what is the ripple effect? What happens to memory usage? What happens to execution speed? How does it impact debugging time? If you are rewriting your answer right now, think about those causal links. Every change has a consequence in computer science. Understanding that consequence is true conceptual understanding.
So, the absolutely crucial point here is that isolating your knowledge is dangerous. The theoretical architecture of your answers must integrate with other areas of the syllabus. And this applies whether you're taking 9618, 0417, 0478, 0984, 0984, or 2210. The overarching rules are the same. Principal examiner reports clearly state that candidates who reference cross-topic connections achieve significantly higher marks. Don't just talk about compilers in a vacuum. Bring in systematic analysis, consider evidence-based reasoning, and connect the translation software back to the overarching system requirements. If the system has limited RAM, mention how an interpreter might take up less memory at runtime than a massive compiled executable. That cross-topic connection is the literal secret to unlocking the absolute highest grade boundaries. Now we transition from theory to practice with Section 3, the procedural framework. How do we take that connected understanding and physically write an answer that secures every single available method mark? How do we build that computer science success blueprint? Well, before we jump into our interactive workshop to practice this, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @aceexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's implement the deconstruct, solve, evaluate loop. This is your exact methodology, and we're going to treat this like a real-time data scan challenge. Imagine a complex computer science chart or scenario prompt right in front of you. You've got 60 seconds on the clock. Step 1. Identify the given information. Extract this constraints immediately. Is it an embedded system? Is it a web script? Step 2, break the problem into logical steps. Step 3, solve systematically. You've got 30 seconds left on that mental clock. Step 4, check for reasonableness. Does your proposed translation method actually make sense for the scenario? Would you really compile a simple script that changes daily? Probably not. And finally, Step 5, make justified recommendations. The examiners award method marks for this exact process, not just a lucky guess. Make your process visible. Applying that framework effectively demands algorithmic thinking. Now it's time for Challenge 2, find the flaw. I want you to think about a flawed sample paragraph where a student just says, a compiler is better because it's fast. What's the flaw there? The flaw is a total lack of algorithmic thinking. Top marks require step-by-step decomposition, discussing appropriate data structure selection, efficient code implementation, and rigorous testing. While these sound strictly like programming skills, they directly apply to your written justifications. When evaluating whether a compiler or interpreter is better, you must mentally decompose how the target program will be processed, implemented, and tested in the real world, and put that explanation into your PL paragraph. Reaching those higher-order assessment objectives means your critical analysis has to be incredibly deep. Welcome to Challenge 3, Speed Writing. You have 30 seconds to mentally draft a perfect paragraph. Go. You must evaluate alternative translation approaches. By analyzing specific metrics, you need to compare time complexity. Does the scenario require fast execution? Space complexity? Are we limited by memory on an embedded system? Edge cases, what happens during a runtime error? And the overall effect on performance. If you aren't comparing these specific metrics before writing down your recommendation, you just aren't justifying it properly. Time's up. Did your mental paragraph include space and time complexity? If so, you're on track for an A star. All right, let's see how all this builds into the most critical part of our explainer today. We are moving into the final stage, Section 4, the top 3 examiner warnings. We know the strategy, we know the PEAL framework. Now let's look at how candidates historically fail to execute it so you can avoid their fate entirely. What we have here is a chronological timeline of how a student's answer typically falls apart under intense exam pressure. Let's trace it. Error 1. They use the wrong algorithm or logic entirely because they misread the context. They rushed, just like Sam. Error 2. They formulate a decent plan but completely forget to check boundary conditions and edge cases, which is where the real complexity of the problem lies. They forget to ask, what if the code contains an error on line 50? And finally,
Error 3, the absolute fatal blow. They write down a generic textbook answer that isn't specific to the context provided. They dump facts, just like Alex. You must actively police your own writing to ensure literally none of these 3 errors creep into your paragraphs.
So what's the ultimate solution to exam hall panic? It's the visual story method. This is an incredible memory hack. When you are studying these complex justification parameters like memory limits, execution speed, and source code security, don't just memorize boring bullet points. Encode them as a sequential visual story in your mind. Picture the specific scenario. Visualize the code being translated line by an interpreter, stopping at the first error. Then visualize a compiler taking the entire batch, translating it all at once, and producing an executable file. Visually imagine the resulting performance impact on the hardware. This memory hack ensures you never miss a step or forget an edge case when that exam clock is relentlessly ticking down.
So let's bring it all together into our final system. There are 3 rules that guarantee top marks. Number 1, command word decoding. Number 2, Peel framework application. And number 3, a time management matrix. Apply these and you win. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here. Keep practicing, and I'll see you in the next one.